Invite Dr. BURAGOHAIN for the next presentation.
Good morning, everyone. So recently we have all been fascinated by the Studio Ghibli images that have been trending. So I'm here to present on another aspect of machine learning that we can use in ophthalmology. So my topic is transfer learning capabilities in artificial intelligence in ophthalmology. There are no financial disclosures. Traditional machine learning techniques are resource intensive and time consuming. Alternative machine learning techniques such as transfer learning can help us overcome this. Transfer learning is basically machine learning technique where a pre-trained model on a larger data set is retrained on a smaller data set for a task which is related but different. By this technique, we skip a lot of steps that are involved in traditional machine learning, thereby reducing time and cost. So the purpose of our study was to make a machine learning model using transfer learning for fundus and optical coherence tomography image classification. We used 572 OCT images with source label of age-related macular degeneration, central serous retinopathy, macular hole, diabetic retinopathy, and normal scans. We also used 400 fundus images to classify diabetic retinopathy. We used machine learning platforms provided by Apple, Google, Clarify, and MedicMind. And we used a paired t-test to statistically compare between the models. Coming to the results, the Google models showed an average accuracy of 0.97 with a precision and recall of 98.21%. You can see the precision recall curves in the figure. The Apple model had a test accuracy of 64% with an F1 score which was highest 0.78 for macular hole, and it was lowest for central serous retinopathy, which was 0.57. The Clarify model had an average accuracy of 0.95, and our highest F1 score was for normal OCT scans, that was 0.98. Coming to the MedicMind model, which was used to classify diabetic retinopathy images, it had an average accuracy of 0.72 and an ROC curve area of 0.75. Now we also compared the models between Apple and Clarify, and it had a value of t-test p-value of 0.768, which was not significant. Using transfer learning, we significantly reduced the computational cost and time that was required. All the models that we trained had competent accuracy scores. The Google and Clarify model had a non-significant advantage, which could be due to their cloud computing that was used. MedicMind model for diabetic retinopathy showed an accuracy of 72.5%, and it also highlighted the challenges that we have with fundus image classification in comparison to OCT scans. The models were not statistically different, so it highlights that cloud-based computing and local hardware utilization did not make much difference. So how is this useful clinically? In medical science, we can see that there can be racial disparities due to the data that we have. So transfer learning can be used for improving the predictions of ophthalmic diseases in a group that is disadvantaged due to the number of data that is available. And this can be used from a data abundant group. These findings also tell us that limited data sets can be used to improve model predictions. To conclude, transfer learning reduced the computational cost and time. It also showed that there was no statistical difference between the models that were used, that is between cloud-based and local hardware-based. And all of these also suggest that we can use limited data using transfer learning to develop machine learning models. Thank you.
Can you just explain what is the difference between machine learning and transfer learning?
So transfer learning basically is a technique in machine learning.
Okay.
So traditional machine learning, we have a lot of steps. We have to collect data. We have to train a model from scratch. So but transfer learning is basically using one that has already been trained on let's say a model that is designed to identify images of humans, people's faces. So we repurpose them to identify OCT images or let's say fundus images. So we help reduce that cost which is used to train the model from scratch from that bulk data set that was already
The
used.
accuracy will be less than the
Sorry, sir?
accuracy will be, precision will be less than actual machine.
Yeah, it will be definitely be lesser than the model that is specifically trained for that purpose, but we have competent models that can be developed.
You haven't compared transfer learning with normal learning.
No, I couldn't compare because the data was not available. Basically.
And which transfer which you actually used?
I have used for models of Apple.
You said you have used a trained database from
Yes, sir.
others thing. Which one was that?
No,
No, the models that are
What
already
model you used to transfer it here?
that was in Google, that was from Apple. These are already trained models.
On what? On what? That's what I'm asking.
Like I said, for
you don't
facial
have-
images, for
No, but you don't have any specific.
yeah,
idea.
specific data I don't have sir, because it's not mentioned in the website. So, ma'am, deep learning is basically it's the same, but transfer learning we are skipping those steps that are needed. Already a model has been trained on deep learning, and then we are using that same model for a different purpose, retraining them basically.
Irrespective of any type of the equipment, as a OCT is there, so many models are there.
Yes, sir.
Use anyone.
Yes, sir. Yes, sir.
any transfer learning app, this has been approved by FDA for
Not yet,
nothing,
sir.
no? Okay,
Yes, sir.
thank you.
Thanks. Sir.
Thank you.